Dear student, today we will discuss on the topic photochemistry. What is photochemistry? It is the study of chemical reaction that is brought about by the action of visible or ultraviolet light. One example is reaction of carbon dioxide with water molecule under sunlight and chlorophyll to produce glucose and oxygen molecule. Grotthus-Dreyfus law, it states that only those radiation which are absorbed by the reacting systems are effective in producing a chemical sense. Beard-Lambert law, the amount of light absorbed by the substance or medium is proportional to the intensity of radiation is known as the Lambert law. Beard law, the absorption of light by solution of non-concentration is given by Beard's law, that is minus di by dt proportional to the concentration. If we combine these two laws, we will get the equation minus di by I proportional to dl by dlc minus di by I equal to k dlc. If we integrate this, then we will get ln I by I naught equal to minus kcl. This equation is known as the Lambert law. The ratio I by I naught is the transmittant and the quantity log I naught by I is refers to the absorbance. Epsilon Cl is called the optical density or the absorbance of the sample. Diagrammatically we can illustrate using this figure. When light falls on the solution with intensity I naught and the concentration of specific amount and the length of the cuvette is L, then the intensity will decrease. If we plot this figure absorbance versus C, then we will get a linear plot below figure. Stark-Einstein law of photochemical equivalence. This law states that each molecule which takes part in a primary photochemical process absorbs one quantum of light causing the reaction. The energy absorbed per mole is known as 1 Einstein. Symbolically, E equal to NaHA equal to NaHC divided by lambda, where c is the velocity of light and lambda is the wavelength of the light absorbed, where Na is the Avogadro's constant. Quantum yield of a photochemical reaction. Quantum yield is defined as the number of molecules of reactant consumed or decomposed or product formed per quantum of light absorbed. This can again be defined as the Number of molecules form or decompose in a given time divided by the number of photons absorbed in a given time. According to law of photochemical equivalence, the quantum ion will always be equal to 1. But reaction with low and high quantum. Now, what is primary process in a photochemical reaction? First step in a photochemical reaction is the absorption of photon of radiation by the molecules in the visible only UV region. Secondary process is the excited state process. A molecule with electron pair and with opposite spin is said to be in singlet ground state denoted by S0, and the excited molecule with two of its electron unpaired and opposite spin is said to be in the excited singlet state represented by S1, S2. The excited molecule in which the two of its electrons are not paired is said to be in the triplet state represented by T1, T2. Below figure is the systematic representation. Middle figure S0, that is ground state, it remain paired, and after in presence of light is V, S1 means that there will be a opposite spin. However, for the T1 it will be similar spin. Spin multiplicity can be calculated using 2s plus 1. When a molecule in S1 S0 state absorbs a quantum of light, it gets excited. The process by which excited molecule loses energy and subsequently reaches to the ground state shown by Jablonski diagram. These are the various lifetime or time period involved during the different process. Suppose from ground state to excited state, the molecular goes to the excited state, and from them it will come to the lowest excited state S1, and they will come back to ground state. If it comes back from the S1 to the ground state, then it's known as a fluorescence. And if it goes and changes spin to the triplet state and it goes back to ground state, then it is known as a phosphorylation. And within the excited state there is some internal vibration, that is known as internal conversion, and similarly for triplet state also there may be internal conversion. These are non-radiative process. Photosynthesis reaction. In some reactions the reactant molecule do not absorb the radiation and no reaction occurs. However, if a suitable foreign substance that absorbs radiation is added to the reactant, the reaction takes place. The atoms of the foreign substance are excited during absorption and they pass on to this energy to the reactant and thereby initiate the reaction. The process of this type is called photosynthesis reaction, and a foreign substance which absorbs the radiation is known as a photosynthesizer. This is the illustrative example. Figure is the illustrative example. Here synthesizer means donor and reactant means acceptor. Here donor will transfer its energy to the acceptor, resulting in photosynthesization. Example of atomic photosynthesizer: cadmium, mercury and zinc vapor, molecular photosynthesizer, benzophenone and sulfur dioxide. Decomposition H2 molecule by mercury vapor under UV light is 253.7 nanometer. This is the reaction involved. Mercury plus Hb to produce excited state mercury. An excited state mercury react with hydrogen molecule to form hydrogen excited state. Then hydrogen excited well or decomposed to form hydrogen atom. Here mercury is the photosynthesizer. Similarly, the photosynthesis of carbohydrates in plant by chlorophyll. Photosynthesizer is chlorophyll. Carbon dioxide plus water molecule under sunlight and chlorophyll will produce glucose and oxygen molecule.